Okay, so let's look at the number of valence electrons in each element. Valence electrons are the ones in the outside shells there. So they're generally here, and we're going to talk about, you want a number, the ideal number of valence electrons is 8. So trying to get to 8. So aluminum has, now valence electrons are only the ones in the S's and the P's. So aluminum has 1, 2, 3. So aluminum has 3. Now to get to 8, it can either get 5 more to get 8, or it can lose the 3 that it has. Is it easier to gain 5 or lose 3? I hope you said, Dr. B, it's a lot easier to lose. That would be correct. 10, here is 10. And so it would be 1, 2, the D's don't count, 3, 4. So 10 has 4. Well, this is kind of tricky because you say gain 4, lose 4. I don't really know. It seems like it should be about the same, right? Well, if you look here, 10 is a metal. It's to the left of the stairs, and metals always lose electrons. So it is a metal, so it is going to lose electrons. Bromine. Bromine is way over here. So this is 8. Bromine has 7. Is it easier to gain 1 or lose 7? I hope you said much easier to gain. Selenium. Selenium is right next to bromine. Bromine has 7. Selenium has 6. So to get to 8, it's much easier for it to gain 2. Okay. Now, here we're wanting to arrange atoms according to their decreasing effective nuclear charge. So the effective nuclear charge is going to be something that when you look on the periodic table, make sure I tell you this right, what's experienced is, we're talking about things that are unshielded. So effective nuclear charge is going to increase as you go across a period, and it's going to decrease as you go down a group. So it has to do with like the shielding effect. So when we look at these, we have sulfur, magnesium, aluminum, and silicon. So these are all here in the third row. So it's going, so we want decreasing effective nuclear charge. So we're all in the same row, so we don't have to worry about it going down. It's going to increase as we go across the group because there's less shielding involved. So each one of these gets more of the full power of the nucleus, each one of these electrons. Okay, so the highest one would be the one furthest to the right. So that's going to be sulfur. Keep going backwards. Silicon. Keep going backwards. Aluminum. Keep going backwards. Magnesium. All right. Now, effective nuclear charge is the premise where we get our trend of atomic radius or size of an atom. So which one is larger? Okay, so as effective nuclear charge increases as you go, that means atoms are electrons are being held closer to the nucleus. So atomic size decreases. So atomic size decreases across a group and increases down a period. So let's look at these. Tin or silicon? Tin or silicon? Which one is bigger? Tin. It's further down the group, more electrons, more orbitals, bigger cloud. There we go. Bromine or gallium? And this is kind of weird because you go, well, bromine has more electrons, but it also has a higher effective nuclear charge. So they get smaller as we go across. So gallium is actually the larger one. Okay, tin or bismuth? It's kind of tricky because if we go across one, they should be getting smaller, but as we go down one, they should be getting bigger. So based on periodic trends alone, you can't tell. More than likely, bismuth would be larger, but only on periodic trends you can't tell. All right, how about selenium versus tin? So we get smaller as we go across, larger as we go to the left, larger as we go down. So tin is definitely the larger one. And then let's do one more in order of increasing atomic radius. So there's 6 of these, so that's kind of tricky. So we want to put them from smallest to biggest. So based on periodic trends, we get smaller as we go across, larger as we go down. So the easiest way for me to do this is kind of start in the top right and kind of work my way back and down and see kind of where I go first. So here, get these where you can actually see them. Okay, we're gonna get to fluorine first. Okay, so we got to fluorine. After fluorine, then we get to what next? Sulfur? Yeah, sulfur. Keep going. Then we get to silicon. Then we gotta go down a row, we get to germanium. Then we go way over and we get to calcium. Then we got to go down to get to rubidium.